Welcome back everyone. So in this session we are going to look upon the definition of segment and as well as how to calculate the area of segment. So let us firstly have a look upon the definition. The region between a chord and either of its arc is called a segment of the circular region or simply a segment of the circle. That is, as you can see, there is a chord AB and the chord has divided the circle into two segments. First one is major, second one is minor. There is one thing, whenever we refer segment, we always by default we assume it is a minor segment. If we are referring to a major segment, then we specifically mention that we are calculating the area of a major segment. Otherwise, whenever we talk about segment, we always mention that we always consider, by default we consider that we are talking about minor segment only. Now let's see how can we calculate the area of the segment. Now in order to calculate the area of segment, what I am going to do, I am going to firstly draw, let's say this is my AB and this is O. Now AB is a chord and over here, as you can see, this shaded part is minor segment and this unshaded part is the major segment. We have to calculate the area of segment. And as I told you, by default, if I say that I am calculating the area of segment, we will be considering minor segment only. So area of segment will be, as you can see, mixed up of, if I talk about, this is a triangle OAB. So if you want to calculate the area of segment, so it will be what? This is, if you just look upon this OAB, this is nothing but a sector, right? So this is what area of sector, and in this area of sector, if I subtract this triangle minus area of triangle OAB, now area of sector again OAB, and area of segment is also nothing but this AB segment, formed by minor segment AB, right? Now area of sector OAB, and we are talking about the area of two shapes, firstly sector and then triangle. So let's calculate each of the areas one by one. Firstly, let's just calculate the area of triangle because we already know the area of sector, we have calculated in the previous sessions. So this is somewhat like OAB looks like, OAB, and if I draw up a perpendicular on OAB, what it will be, this right here is nothing but the radius, right? And this is obviously 90 degree, and let's say I name this at AC. Now as you can see, this entire angle is what? Theta. So this will be theta by 2 because this is an isosceles triangle. So and this will also be theta by 2. This is an isosceles triangle, and in isosceles triangle, if we drop a perpendicular, it bisects the angle, right? Now if this is theta by 2 and I want to calculate the length of AC, now as you can see, AC, with the help of trigonometry, we can definitely calculate the length of AC. As you can see, with respect to this theta, this AC is what? Perpendicular, and this is what? My hypotenuse. So we have sine theta by 2 as, AC upon OA, and from here I know that OA is nothing but R. So from here AC will be R sine theta by 2, and similarly I can calculate the length of BC will also be r sine theta by 2, and if the length of AC and BC is r sine theta by 2, my length of AB will be what? 2r sine theta by 2. I hope it makes sense. Similarly, let's calculate the length of OC as well. Now, the length of OC will be what? See, OC is nothing but base in this case. So, in order to calculate the base, what I'll be doing? I'll be doing cos theta by 2. And cos theta will be what? OC upon OA. OC upon OA. So, if I want to calculate the value of OC right from here, what I'll be getting is OA is nothing but R. So, that will be R cos theta by 2. I hope it makes complete sense to you. Now, we have to calculate the area of the triangle OAB. So, area of the triangle AOB will be what? This right over here. This will be what? Half into base into height. And as you can see, half into base into height. If I put base, this base is AB is what? 2r sine theta by 2, and into height will be what? R cos theta by 2, and this further can be written as half into 2 cos theta by 2 and sine theta by 2, and then this will be 2r square, and if I take 2 cos theta by 2 sin theta by 2, so this will be formula of sin 2 theta, that is half into r square into sin theta, right? And this will be the area of triangle OAB. Finally, now what about the area of the arc OAB? So, if I calculate the area of arc, so as you know, if this is theta, right? So, the area of arc will be what? Pi r square by 360 degree into theta only. Now, we can calculate the area of segment as area of sector OAB we already have, pi r square upon 360 degree into theta minus, and we have area of triangle as half r square sin theta, right? Now, I can take r square common, and what I will be remaining is pi into theta upon 360 degree minus sin theta divided by 2. This will be the area of segment, right? So, that was all about this lecture, and I hope you perfectly understood how we can calculate the area of a segment. It's better to remember this formula. Otherwise, you already have understood how we can obtain this formula, but it's better to cram this formula right away because it is a bit lengthy to derive this formula, right? So, that was all about this lecture. Thank you so much.